So the last thing we're talking about with one sample with chapter 9 is something called errors and power, right? Errors and power. So when you think of an error, something's an error, what does that mean? They're wrong, right? They're wrong. That's exactly what an error is in statistics. They made the wrong decision, right? We have two choices, right? What are our two choices when we do a test? Or not two choices, or two conclusions. When we do a test, right? We go through all the steps of a test, we get to the conclusion. What are the two choices we can make? Reject or fail to reject, right? Errors are when we do one, but it was wrong. So when we reject a claim, that claim is wrong, but the claim was actually true. Okay? Or we say we fail to reject. We don't have enough information. Our p-value is too high, when in fact their claim is wrong. Okay? So when you think of errors, you think of I did something wrong. Not necessarily. Errors in statistics aren't necessarily. Errors occur because the sample that we gathered doesn't reflect the population. Okay? And we don't gather samples, right? We don't gather samples. The sample's always given to us, right? So when you think of errors, it's not calculations. So we're not talking about calculations where you were crunching the numbers and you did a that's not what we're talking about here. Errors are not that. Errors are the sample that was given to me does not reflect the population. Okay? So when you think of errors, it's not like a calculation error. It's not like you were trying to do a multiplication problem and you accidentally got one of the numbers wrong. That's not what I'm talking about with errors. Okay? So it's like, for example, one example of an error in testing is, hopefully it's never happened to you guys, but when you're taking a medical test, right? You take a test they have a test for the flu, right? You go to the doctor and I think I have the flu. They give you a test, right? COVID tests is another one, right? They have all these types of tests for diseases, right? False positive. What is a false positive? Exactly. When you come back and they're like, you're positive, but you actually don't have the disease, right? It happens. Doesn't happen often, but it happens, right? It's not a calculation error. It's not an error where the machine messed up, right? The machine is a machine. It's built to do the same thing every time. So it's not like we don't throw the machine away, right? It's just an error. It happens, right? The sample they took, whether they took a saliva sample or a nose sample or a blood sample, it was just a bad sample. It didn't reflect what was actually happening, right? That's what it was. Or a false negative, false negative. False negative, you take a test. You're negative, you're good. When you actually have the disease, right? And depending on what kind of disease it is, that could be pretty bad, right? What could be bad about a false negative? What's a consequence of a false negative? Depending on the disease, yeah, if you're not treating it, you could die, right? If it's a pretty severe illness and you don't treat it correctly, you could die. All right, what else? Exactly. If it's COVID or if it's something like that, you could be infecting people. I don't have the disease. I tested negative, right? So there always is that chance. Now, does that happen a lot? No. Exactly. When it happens, we don't throw out the test and say this test is wrong, right? The machine miscalculated. No, it was just the sample itself didn't reflect what was going on, right? So when they stick you know, how many people have had COVID tests? Everyone, right? Everyone's had a COVID test at least once. What's that? Yeah. So the long Q-tip in your nose, right? Sometimes they don't stick it far enough, or sometimes they don't swab correctly, right? So it's a bad sample, right? Now, if someone's giving you the test that knows what they're doing, that chance is very small, right? If it's a nurse who's giving you that test, they do this all the time, right? But sometimes it's self-test, right? The self-tests. So people are like, oh, my self-test came back negative and I actually had it, or the other way around. Well, people have been known to not do it correctly. No one likes to stick this long Q-tip up their nose, right? And you have to do it for a while. What is it, like 5 times you have to swirl around or something like that? And then no, something like that, right? Sometimes people don't do it correctly, and then it comes back and it's negative, right? That's what I'm talking about. Okay, that's what I'm talking about. I'm not talking about um, calculation errors. Okay, it happens. Doesn't happen often, but it does happen. It is possible, right? Okay, so we have two types of errors in statistics. We have a type 1 error, also known as an alpha error. Okay, most of the time you'll see type 1 error. Most of the time it's called the type 1 error, but sometimes it is called an alpha error. And I'll explain why it's called alpha error later. But for right now, just go with it. This occurs when we reject the null hypothesis. And guess what? They weren't lying. It's actually true. Okay? The other type of error is called a type 2 error or a beta error. Okay? Type 2 error happens when we fail to reject the null hypothesis. I don't have enough information. I don't have enough evidence to say you're wrong. My p-value was too high, right? But guess what? I should have rejected because what they're telling me, the claim is wrong. Okay? So those are the two types of errors. So why is there check marks in the other box, the other two boxes? Because that's what we want, right? That's what we want. If we reject, we actually want them to be liars. I don't want to call anyone a liar who's not lying, right? I don't want to say your claim is wrong when it's actually right. So we want this check. This check right here, same thing, right? Fail to reject when they're actually their claim is is true. Okay, that's what we want. The words for these, they didn't put it in here, but it's called power. Power, that's the other one in errors and power. Power is what we want. We want to do the right thing, right? We want to do the right thing. We want to make the right decision. If I actually have COVID and I take a test, I want it to be positive. I don't want it to be negative, right? Or the other way around. If I take a COVID test and I don't have COVID, I want it to be negative, right? That's power. If I don't have it, right? Otherwise, it's an error. Okay. All right. So let's look at some examples here. Give me 1 second. So the thing about this is they will always, always, always give you the hypotheses. You don't have to make up the hypotheses on your own. When they want you to talk about type 1 or type 2 error, they will always give you the hypotheses. Okay? So the hypothesis here, so consider a test. We kind of talked about this for a serious disease. We have two hypotheses. The null is the person is healthy. That's the claim, right? If you go to the doctor, you want them to reject that claim. I'm going to the doctor because I'm sick. So reject that I'm healthy, right? Tell me that I'm sick or else, it was a waste of time. The alternative is that they're not healthy. I think I'm sick. I'm going to the doctor. Okay? So what would be an example of a type 1 error? Okay? So type 1 error happens only when what? When we reject. So if we were to reject this claim, what would that sound like in words? Person is not healthy, right? Person has the disease. So the person or the patient, probably should say patient, is not healthy / has the disease. Right? That's what we say. We say the patient is not healthy or they have the disease, either one, right? That's what we say with our tests. But what happens? There you go. But they actually are healthy. They don't have the disease. Consequences. So sometimes what they're going to ask you to do is state in context. What we just did is the context of a type 1 error. So this is what I'll get a lot. This is what I'll get a lot for on these questions. It'll be the same question, and then someone will write this in here. They'll say type 1 error. Reject the null hypothesis when in fact it is true. What's wrong with that? There you go, 100%. It's not in the context. Could that be an answer for all type 1 errors? Like that's because they're always going to ask you what is an example of a type 1 error. And I'll have some people put that. They'll put reject the null hypothesis when it was true. That's the textbook definition, right? We want it in context. That's why we put it in context. That's always in context. Okay? And then they're going to ask you, okay, so now that you know what a type 1 error is, what is a consequence? So what is a consequence of what we just wrote down? Like a real world consequence? Yeah, in context. Oh, they might die. Oh, no. There you go. Waste time. Treatment they don't need. Receive treatment or medication they don't need, right? That's it. You don't have to go any further. You don't have to say they're going to die or anything. We're not doctors. We don't have to determine that. But they will receive treatment or medication that they don't need. The doctor is treating them for the disease. And if it is truly a serious disease, then the doctor's probably going to do more testing. So if it is come back, I shouldn't say no one, but I don't think it happens very often that someone gets diagnosed with cancer and then has to go through cancer treatment when they don't have cancer at all. If it came back, if they got a false positive, then eventually down the line before they get treatment, they'll, because they do x-rays, they do MRIs, they take blood. That's why doctors, if you've ever been to the hospital for anything, they always do all kinds of battery of tests, right? That's why they do it, because they don't want to look at just one thing and see, they're like, you know what, I think this person has this, and then go with it. What if you didn't have it, right? That's why they do battery of tests to make sure that the person does in fact have that disease, and it's this disease that I'm going to treat them for. Okay, so what's an example? Same question. What is the example of type 2 error? In context, what is an example of a type 2 error on the backside? The patient is healthy, but actually is not. There you go. So type 2 error only happens when we fail to reject. So we fail to reject that they're not healthy. Doctor says patient is healthy. When they are not. Okay? When they actually are sick, or they actually do have the disease, right? So what's a real world consequence of that? Disease goes untreated, yeah. Disease goes untreated. No treatment, yeah. However you want to say it. So whatever the illness is, if it's like something like cancer or something like that, then, that's pretty bad. If it's something, so it just depends on what, we don't have to put all of that. We just said disease goes untreated. Okay. All right. So now what I want you to do is I want you to try one on your own. The Lay's Chip Company. I'll read the first part with you guys, and then I'll let you guys work on it. The Lay's Chip Company tests a sample of potatoes from a truckload for E. coli. E. coli is a bacteria, I believe, a bacteria that sometimes, if not, it could get in food and cause some serious stuff if people ingest it. To determine whether or not to accept the truckload. So the hypotheses are, so the Lay's company who makes potatoes, or who makes potato chips, right? Potato chips, you guys have probably seen them or eaten them. Lay's doesn't make the potatoes. They get it from farmers. Farmers grow the potatoes and then they buy from the farmers and then they make their potato chips and then they send it to the stores to sell. So farmers, when the farmers are sending it in to Lay's, first thing Lay's does is they want to run a test to see if the potatoes are okay to make, right? Or they'll just reject the load and say, I'm not paying for this load, right? That's what they say now. So as they receive the load to make chips, the hypothesis is, okay, these potatoes are good. That's the claim the farmers are making. The alternative is, no, they're actually bad. Okay, so I want you to come up with a type 1 error, type 2 error. Okay, and then tell me from the potato supplier, so from the farmer standpoint, which is worse, type 1 or type 2? And then the other way around, from Lay's, which one is worse, type 1 or type 2? Okay, I'll give you guys a few minutes and then we will talk about it. Alrighty, so if we have a null hypothesis that they're good, potatoes are good, and the alternative is they're bad, what's an example of a type 1 error?
They were bad, but they were actually good.
So say it again.
What? Was that wrong? Was it opposite?
So they tested
Positive for E. coli when they're actually fine potatoes.
Okay, so we rejected the null, which just said they're good, so that means they're bad when they're actually good. Exactly. So any way you want to say that. Rejected the batch or truckload when potatoes are actually good. Good. Okay. Type 2 error. What's an example of type 2 error? So we accepted the load, accepted the batch when we should have rejected, or the potatoes when potatoes were bad. Okay. Good. Okay, so if you're the potato supplier, so if you're the one that supplies the potatoes, which one is worse, type 1 or type 2?
Type 1.
Why?
Money.
Type 1 because?
No money. You don't get any money for that.
Oh, but there's also a really good argument for that.
So type 1 because financial.
Yeah. I mean, type 2 also works. Yeah, the reputation of the potato farmer is over.
I'd be more concerned about cash.
So let's run with let's say a type 2 error up here. So type 1 is financially bad for the right, because they're tainted, right? You can't send them to anyone else because they've been labeled as bad.
You can't get a retest. So one and one.
But yeah, you could. Yeah, your only option would be to eat them on your own, right? Because you know they're good. But a type 2. So let's go with a type 2 there. Let's say, what would be the penalty, or what would be the consequence of a type 2 error to the potato supplier? So millions of people get sick. There you go. There you go. There you go, right? Exactly. And that's what I was going to say. Potato farmers are to blame, but they're not the ones that are going to get they might get sued later on by Lay's, but publicity wise, it's bad for Lay's. PR wise, it's bad for Lay's because yeah, you're reaching into a Lay's bag and you're eating the Lay's, right? Which leads me to my next point. Which one's worse for Lay's? Type 2. There's
Type 1 would be worse.
there's no good. There's no good, right? So it's not like a type 1 error would be good for Lay's. Or type 2 errors would be good for potatoes, but worse. I'm talking about worse, right? Type 2 is bad for Lay's because now they've gotten people sick, even though, like you guys have said, it's not their fault. Well, yes and no, it is kind of their fault because they were the ones in charge of checking the batch, but they didn't produce, right? So yeah, so type 1 and type 2 for both, but which one's worse? Yeah. Okay. All right, so here we go. So a school district is considering purchasing laptops or Chromebooks for all of its 10th and 11th grade students in hopes that using the devices will improve student achievement on year-end exams. So if we were to do a test based off of this prompt, would it be a one-tailed or two-tailed test? So how do we know if it's a one-tailed or two-tailed test? Well, how do we know? What's the
Improve. You can only improve by going up.
Exactly. We only care about improvement, right? So that's what we're going to check to see. Exactly. If the scores just changed, right? So it's going to be a one-tailed test. Yeah. Okay. So now finish out the rest. Okay. So what would a type 1 error be? Yep. Reject will not improve. So that means it did improve. So student achievement did improve, or no, because it didn't actually improve. So student achievement noted as improving when it really didn't. So student achievement noted as improving when it really didn't. So what would be a type 2 error? So student achievement, but it actually does. Noted as not improving, but it actually did. Not improving, but actually did. So if I'm the school district, which one is worse? Type 1 because?
You wasted money.
Financial, right? Noted as improving, so when it really didn't. So you're saying the program works. So what would be the consequence of a 2? So yeah, so you're not, so your reputation as a district, your test scores show that it's not improving, but you actually did improve.
How do you miss that though?
Well, no, when
Yeah, number one is money again.
yeah, number one's financial. Because if a program's working, you're probably going to expand the program based on data that's not true. So type 2 error is student achievement noted as not improving. So the Chromebooks weren't helping anyone, but they really were, right?
So you miss out on a good program.
There you go.
Or you waste money expanding a useless program.
There you go. Yep, those are the errors, right?
This would be such a fun thing to start with here. Imagine all the stuff you would say.
Okay, so kind of the idea. So kind of the idea of this, we've been talking about like criminal trial, like guilty, not guilty, right? We never say innocent. We always say guilty, not guilty, right? So let's pretend we have a defendant we know is guilty of a crime. We know they did it. Because somehow you know they did it. I don't know how, but you know they did it.
I was there.
Exactly. You might have been there. You might have been one of the co-conspirators. So you know they did it. The defendant is innocent. That's the null. The alternative is they're guilty. What do we need to convict the criminal? In other words, reject the null hypothesis. If you reject this null hypothesis, they're guilty, right? We need strong evidence, right? Beyond a reasonable doubt, right? Without it, we risk committing a type 2 error, right? Type 2 error is failing to reject, you're not guilty, when they actually did it, right? So here's another question. Which is worse in our criminal justice system? A type 1 error or a type 2 error?
Letting a guilty guy walk or letting an innocent guy go?
That's the question. Letting a guilty guy walk or letting an innocent guy go to jail. Which there's an answer. There is an answer. It's not a philosophical thing. There actually is an answer in our justice system, in the American justice system. Not all countries have this, but in the United States justice system, no, actually, there you go. In our justice system is based on we'd rather see 100, 1,000 guilty guys walk than one innocent guy have to suffer the consequences, go to jail. That's the way our justice system is written. Exactly. So other countries, no, that's not the case. Other countries, if they send a couple people that are innocent, oh well, it's the risk of doing business, right? But the United States now, does it work every time? No, but that's what it's built on. It's built on we'd rather see 100, 1,000 guilty men walk than one innocent man have to suffer. Okay. Okay, so let's see here. Okay, let's skip this one. We're going to skip this example. There's an example here about type 1 and type 2 error about the police department. You guys have done stuff like this already, so let's skip this and we'll have time. We'll come back to it. But I want to talk about calculating. How do we calculate a type 1 error? Because they're going to ask you to calculate a type 1 error. They're going to say, what is the probability in this question that you made a type 1 error? Okay, so type 1 error. Remind me again. What is a type 1 error? Rejecting the null hypothesis when is true. When this guy is true. So rejecting their claim when it's actually true. Okay. And when can we reject a claim?
When the p-value is what, less than?
When the p-value is smaller, right? So let's say we have an alpha level of 5%. So what you're saying is, for me to reject, I have to have a p-value smaller than 0.05, right? If it's above 0.05, anything above 0.05 can't be a type 1 error, right? Can be a type 2 error, but can't be a type 1 error, right? Following me? So what is the probability of making a type 1 error in that case? 5%. 5%. So the probability of committing type 1 error is always going to be equal to alpha. Always going to be equal to alpha. So whatever alpha is, because we can't go above it. The second we go above it, we can't make a type 1 error, right? We can only make a type 1 error if we're within alpha, right? So that's kind of the rejection. We call it alpha is kind of the rejection area, right? If it's a one-sided test, all right, and here's my mean, and it's a greater than situation, right? Let's say that's 5% right here. For me to reject, I have to have a t-score or a z-score inside of that, right? I have to be within. The p-value has to be smaller than this, right? It has to fit inside of there. So once it breaks out of there and goes to the bigger area, it's no longer a type 1 error. Now it becomes a type 2 error. Okay? So the short answer, the short story is the probability of committing a type 1 error will always be the same as alpha. Whatever alpha is, that's our type 1. That's a probability of committing a type 1 error. There is no calculations. It's just you know it or you don't. Okay? Power. Okay, so I told you guys power. Let me go back to the very, very front. I told you guys power was both, right? Power is actually just this guy here. So make sure you change that. Power is only this guy here. That's power. Rejecting a false null. So rejecting a null when it was actually false. Okay? Rejecting a null when it's actually false. Okay? Power is what we want. We want to reject, right? If I'm a prosecutor and I have that person on trial for whatever they did, I want the jury to say guilty, because why would I even bring them up on charges if they didn't do it, if I don't think they did it, right? So that's what we always want. We always want to reject. Every time we do a test, we want to reject. But we don't want to reject unless it was actually false, right? We don't want to reject something that was actually true. That's called power. Okay? So do we want power, the probability of power, to be high or low? Why high? We want it to be high because the higher it is, the more likely we are to reject a false claim. Right? True. Yep, that's true. So how do we calculate power? Power is 1 minus type 2 error. 1 minus type 2 error. Now, you won't have to calculate type 2 error. That's not required. But sometimes they'll tell you what a type 2 error is. The probability of a type 2 error is blah. Well, 1 minus that. Because for power to be true, for us to get up here to power, right, there has to be two things. If it's false, we have to reject or fail to reject, right? Only two things can happen. So that's why it's 1 minus it. Okay? All right. Okay, so what I want you to do is do the example right after it. CDC, Centers for Disease Control. Give you a few minutes. It's probably going to take you longer to read the thing than actually solve it. Okay, so the CDC claims that 11% of American children ages 4 to 17 have ADHD. A company claims that it has developed a new vitamin tablet that will lower a child's risk for ADHD. Researchers will administer the vitamin tablet to 200 volunteer children under the age of 4 with parent consent. The subjects will be tracked through childhood, and the researchers will record the proportion of subjects who end up developing ADHD. Okay, so the researchers will perform a test at the 5% significance level for. So their claim is they're comparing it to 4 to 6 17-year-olds, 11%. They're seeing if it's lower, right? They want to know if it's lower. If it's lower, then there's something to it. There's something to this drug. Okay. P is the true proportion of all children, like those in the study, who would develop ADHD when given the new vitamin tablet. The new vitamin tablet is too expensive to produce, so researchers would like to be convinced that it really does do what it's supposed to, reduce the risk. So the power of the test to detect that the true proportion for for 5% significance level is 0.937. So what does that number mean? It's a probability. So not in context, it's the probability of correctly rejecting a false claim. So how do I put that in context? I'll give you a start. The probability of what?
Probability that we reject the company's claim is 0.937.
Okay, so the probability of rejecting the company's claim of what? What was their claim? So the claim is right here. That's the claim right there. So the null hypothesis is the H sub 0, but you got to explain the rest.
I can't just say the company's claim.
Well, what is the company's claim? That's what I'm asking.
The true proportion of children,
Like those in the study.
is who would develop ADHD when given a new vitamin tablet is 11%.
So yeah, so essentially that. Just kind of putting it in because we want to put 0.93. So the probability of rejecting the company's claim, and then you can put in parentheses 11% of American children, right? That number represents 11% of American children who have ADHD. So the probability of saying that these same children will have a p-value, or not a p-value, a probability of getting ADHD is 11%. The probability of rejecting that claim is 0.937. Mm-hmm. Yeah, you probably should say that because, otherwise, because you're right. So we should say the probability of correctly rejecting. That's probably a better way of phrasing it. Correctly rejecting the company's claim the true proportion of children that develop ADHD. Oops, not 0.0. Is 0.937. The probability of correctly rejecting the company's claim is 0.937. That's what we want to do, right? Okay, last thing. We're going to skip this one. Actually, we'll do this one on Monday. But the last thing we're going to talk about is ways to increase power, right? Power is good. We want power. We want to reject something that's false. So we want it to be as high as possible. We want to get a number that's high as possible. So there are 3 ways to do it. One way, hold on. Perfect. You can just leave it right there. Yeah, you can leave it right there. Increase alpha. Increase the alpha level. Is that a good thing or a bad thing? Well, yeah, why is it bad? Why is it bad to increase alpha? Exactly. It lowers the amount of evidence needed, right? And if we really want to reject, that's like saying, you know what? I can't make it over this bar here. So I'm going to lower the bar. It's going to be easier to jump over, right? Not necessarily good, but you're achieving what depends on what your goal is, right? So increasing alpha is one way. It'll lower the probability of a type 1 error, but it increases lowers the probability of making a type 2 error because power goes up, right? But it increases the probability of making a type 1 error. So you're kind of robbing Peter to pay Paul. Okay? Increase n. What is increase n? Sample size. Increase sample size. It lowers both probabilities of a type 1, probability of a type 2, which is good. And it increases power, but it takes a larger sample size. So you have to get another sample. Increase the effect size. This one you don't have to worry about. We don't talk about effect size in this class. Okay? We don't talk about effect size. So don't have to worry about that. So the ones for our class that we are concerned about is 1 and 2. Okay? All right, so we're going to finish up. We're going to do a couple here, and then we'll finish up, and then the rest of the class, I'll probably just let you guys work on the assignment. So there's nothing new assigned over the weekend. Okay?